Okay, this is the 160 Gnome at 1/3 scale on my new Vickers FB5, which is called the gun bus. As you can see, this is a rotary, 9 cylinders. It's a 4-stroke engine, single valve monosop. There's no carburetor. This is the 3-cam version, 160. The earlier one was a 9-cam, 100 horse. This has 4 speeds. It had a mechanical selector geared to the engine, and it would fire all the cylinders eventually. It had 0, 1, 2, 3, 4 positions. 0 was off, 4 was high speed. High speed, it takes 2 revolutions to fire all the cylinders. And 3rd speed, it takes 4 revolutions. 2nd speed, 8 revolutions. And the 4th speed, 16 revolutions to fire all the cylinders. Being 4-stroke, it goes on high speed 1, 3, 5, 7, 9, 2, 4, 6, 8. On a 3rd speed, it would go 1, 5, 9, and eventually it would fire all the cylinders in 4 revolutions, and so on. I am cutting the ignition signal with an electronic flip-flop circuit, and it seems to work pretty well. Top speed on this at number 4 is about 2,800 RPM, 2,400, 1,600, and the first speed is one that really won't quite run on the ground, but it runs for landing when you're windmilling in. The propeller helps turn the engine because you're only firing like once every 2 revolutions. It's kind of like the hit and miss engines, but that's what they did. And they, like I said, there's the high speed is governed only by prop load. There's no other control. You have a metering valve on the fuel, but it's pretty much a waste oil and waste gas. It's using castor oil, and it runs, of course, through the hollow crankshaft to a twin piston oil pump, which is in the very bottom of the engine, and it's geared to the main drive here. You can see this turning here. So in the very bottom here is a twin piston oil pump running one to the mains and one up through the cam area. And of course it ends up in the crankcase. Gasoline is just there's a tube, it just runs into the crankcase, and it's dumped in the crankcase, raw fuel. This engine in this cycle gets its intake, is air through intake through the exhaust valve, and then at the very bottom, 20 degrees before bottom dead center, holes open up for a port, and it lets in raw fuel, and of course some of the oil, and that's how it gets its charge. Other than that, it was a very simple engine, and most of these, of course, were just running wide open. And so the pilot had nothing else to worry about. He could tend to his business of piloting, and the engine just kind of ran itself. But they needed all the power they could get. As you notice, they had bare spark plug wires. This is a 2-plug engine. They had a secondary magneto for their high speed they could switch on for reliability. I just run the one, and it goes to a phenolic distributor ring, and there's a brush at 20 degrees advance over here. Let me show you where it is, over in here. And there's also a hole in the mounting plate for the other side, 20 degrees, if you wanted to run this thing clockwise. We're running it counterclockwise. This is a pusher prop, 35 pusher prop, made by Tennessee Propellers. Spark plugs are little quarter 32 V3s from Paul Knapp. So I'm running gasoline and castor oil, and this engine took about 5 years to build it and a year to just debug it. I had to pull the pulsars outside of the cockpit so that I could see them. They just are just way too small to. That's one for each oil circuit. I'm using a fuel tank in the upper wing. This was the original fuel tank. And let's see, going back on this side over here. And they had a small tank underneath. And this is where the castor oil goes in. This is the pilot's area. His stick was hooked to the elevator bell crank, and his feet did the rudder. The gunner sits up front with a Lewis Mark I machine gun, and this one here, like I say, was an infantry model with the cooling chamber on the outside. Later on, they knew they didn't need the cooling, and of course, they only had a few shells with them. They had like, I think it was later on, it was like 96 shells per drum. And maybe had a half a dozen drums, but that's it. So they just, according to the literature, they just made some bursts of 3 or 4 shells. They used the tracer bullets were more effective than the sights. So they kind of say that action happened so fast that they would just use the tracer bullets and they were more effective. This total plane weighs in around 70 pounds. There's 13 pounds of lead up in front here. Let's see, there's a big, you can hardly see it, but there's a big lead weight up in the front. Now we're going to start this engine. I don't think you're going to be able to hear anything as far as me telling anything, but you'll notice we have to start on high speed. First thing you do is you find a open store in the bottom, and we dump in some fuel, shut off the fuel, mix it around, then turn on the ignition contact, and then once he fires, we turn on the fuel lever, and like I said, she's starting up on high speed, and we'll work with the top 3 speeds, 2, 3, 4. And then you'll notice when I do get down to the first speed, it needs a little more power. So when we're windmilling coming in, you're supposed to be able to use that.
Fly with that wing.
Okay, we're going to go and try to start it now. Thank you.
Okay, you're on right now.
Okay. Contact. Now, like I said, it starts up on high speed. Ready? Sorry.